In this screencast, I'm going to demo writing a function called maxlist that takes two arguments, a pointer to a list of integers, and the size of that list, and it finds the maximum element from the list. This is similar to one we demoed in class, but we'll do it a little bit differently, and I'm going to show kind of the process of writing assembly language. So I'm running on Orpington. I have an editor window opened. And first I'm going to get some of the boilerplate out of the way. I'm going to declare that the function I'm writing is global. It's called maxlist. I'm just going to write this function in this file. I'm also going to show how to write the underscore start code block in a separate file. So this one, just to keep things clear, is going to be just the function maxlist. It needs to be in the text segment. And I'm going to declare that it's a function to help the debugger out. Write the label for the function itself. And now where do we go from here? We know that the first two parameters will be passed in R0 and R1, so I'm just going to write a comment that indicates what I expect. R0 should be a pointer to the list, and R1 should be the size of the list. So that's what it looks like when it's coming in. It basically looks like a C function that would be declared like this. So that's our goal. Now, to start out, I'm going to start at a kind of a higher level and sketch out what the function is going to look like. So I'm just going to do that in the comments here. We'll do some Python-like pseudocode. So I'm going to start with a counter and say I equals 0. I'm also going to keep track of the largest value we've found so far. And I'll initialize that to the first element of the list. We'll guess that it's the biggest one, then we'll scan the rest of the list to see if we can find anything bigger. I would structure this like a while loop, or I'm going to write the structure that way. So I'm going to say while I is less than size, and then I'll indent Python style. What we're going to do is go look up the candidate, so we're going to grab the next element from the list, and then we'll decide if it's the new best value so far. We're kind of breaking this into several steps because that's how it will work in assembly language. So I'm going to say if the candidate is bigger than the best value we've found so far, then what I want to do is say that that is, in fact, the best value we found so far. And in any event, I'm going to say I equals I plus 1, so I can continue on the loop. And we'll let the while loop finish, and then when we are finished, we'll return the largest value so far, which is now the largest value in the entire list. So that's what it would look like, roughly speaking, in Python. We're not writing in Python, so let's go and rewrite it, or kind of refine it, and make it a little closer to assembly language. So some of the things we can't do in assembly language. First of all, we have this while loop, while I is less than size. What I want to do is convert that into labels and go-tos. So I'm going to start by doing it like this. I'll replace this with one that says if I is greater or equal to size, then quit. Go to quit. Or actually, I'm going to try it a different way. I'm going to structure it a way that I kind of like better, and which is to move the test down to the bottom. So instead of saying while I is less than size, I'll say if I is less than size, then go to the top of the loop. So I'm going to put a label up here that I'll call loop. Let's see, maybe we'll go ahead and indent things a couple spaces, again, to start making it look a little more like assembly language. So now we have I equals 0, so far equals the first item from the list. We have this label for the loop. We say we grab a candidate from the list. If it's better than what we've seen so far, we store that as our best value so far. We increment I, and we see if I is still less than size, then we go back to the top of the list. Now to make this like what we had a moment ago, we still need to come up here and tell it to branch down to the condition. If this loop isn't supposed to run even once, we need to be able to skip over it. So I'm going to just say go to the test. and I'll label this down here, the test. So now we have something, it's looking a little less like Python, but we're getting closer. Now note with my if condition down here on line 19, I've made it so that I'm doing a simple comparison of two numbers that I've already loaded, and the condition of the body of the loop, what happens if I is less than size, is a simple goto. That's something that will translate very directly into assembly language. Up here I have another if statement that's not quite like that, and so I want to transform this so that it looks more like the one on 19. So what I'm going to do is invert the condition. If candidate is greater than so far equals candidate. So what I'm going to do is say if candidate is less than or equal to the value we found so far, then let's not overwrite it. Go to keep old value. And we'll put in a new label here, keep old value. And now we can reduce the indentation level of this code. So now it reads, we get the candidate. We see if that candidate is not anything interesting, it's not better than the best value we have so far, then skip over the line that was going to record candidate as so far. So we go down to keep old value. Otherwise, we say so far equals the candidate. So this is going to do exactly what we did before, but now it's in a form that's a little bit closer to assembly language. Now, I can improve this just a little bit. I'm going to do a little bit of optimization here by noting that this I equals I plus 1 could actually be moved up a couple of lines. The only place I rely on the old value of I is when I'm loading list sub I here on line 14. So I'm going to move I equals I plus 1 right below that, so I get candidate equals list sub I, then immediately increment I, and now keep old value and test are the same label. So I'm just going to get rid of keep old value and change the goto that went to it to goto test. So here's a nicer structure that will work pretty well as an assembly language program. I equals 0, so far equals list sub I, or list sub 0, so we grab the first element of the list, and then we skip over the loop body and immediately see we go down to where the loop is tested. And it says if I is less than size, the go to loop, so it immediately jumps back up. Now that skipping down only happens the first iteration of the loop. From now on, there's just a test at the bottom that jumps back up to the top. We grab a candidate, the next item in the list. We check, we increment I. We compare our candidate with the best value so far, and if it's not an improvement, we skip over the next line. Otherwise, we record the candidate as the best value so far. And then it falls through. So once line 17 runs, it immediately falls into line 18 and line 19 and performs the test and goes back to the top of the loop if we're not finished. And then we have return so far. So I've got my structure in place. Now let's go and actually write that as assembly language code. So when it starts out, I'm just going to reorder that. R0 is the pointer to the list and R1 is the size value. Now, those are actually perfectly fine places to leave those values, but I'm going to move them up into some higher numbered registers, partly just to demo how to do that one more time. But also, I want to use R0 as my so far variable, because when the function is finished, the value that I return needs to be in R0, and so I'd just like to keep it there from the beginning. You don't have to do this. I could say that when the function is finished, I move that value into R0, but again, this is just for a demo. So the first thing I'm going to do is push R8 and R9. I've just picked a couple registers that I'm going to use to store those values. So now I'm going to move R0 into R8, and I'm going to put a comment out here that indicates what I'm doing. I'm basically saying that R8 is the pointer to the list. And then I'm going to move into R9, the value that's currently in R1, and that says that R9 is the size of the list. So now that R0 is freed up, I can use it as my so far variable. And so I'm going to load the first item of the list into that. Well, actually, let's go down here to our pseudocode. So for I equals 0, let's pick a register to use as I. I'm going to pick R1. So I'm going to say move R1, the number 0. And over here, my comment, I'll leave this comment over in the right margin, indicating that I equals 0. So R0 equals I equals 0. So here I've chosen to use move to load a constant into R1. I could have just as easily have said LDR R1 equals 0, but I wanted to demo that those are the same thing. So I've loaded a 0 into I. Whoops, not R0, R1, excuse me. I'm just going to reorder this since that's the order the registers are in. So I wanted to say so far equals list 0. Well, that's going to be an LDR. I'm going to load into R0 the value pointed to by the list, and the list pointer is now in R8. So if R8 is the address in memory of the value that I want to load, if I do LDR R0 square brackets R8, that will load the first value of that list into R0. Then our next instruction is to go to test. So I'm just going to say branch, and I'm going to use the format of, just for our purposes here, I'm going to say that, let's see, test is our second label, so I'm just going to write it as go to 2:test. And when I actually do the branch, I'm going to use one of those local labels, so just a numbered label. This says I'm going to label 2, and it's a forward branch. So over here in the comment, I've just preserved the fact that I had called it test before, but it's actually label number 2. So I'm just giving myself some hints. Now we have the label loop. So loop is going to be label 1. So I'm going to come and call this 1 in my comments, and I'm going to find the reference to it and change that just to put a note for myself. Okay, so now I've got my labels commented a little better. So what do we do at the beginning of the loop? Well, we want to load the candidate register with list value sub I. Well, we haven't picked a register for that yet. So let's do that now. Let's say R2, since that's a scratch register that we haven't used yet. So I'm going to load a value into R2, and the value that I'm going to load is coming from memory. The memory location is where the list begins, plus the value of I times 4. Oops, I didn't give myself enough room. I'm going to tab all of my inline comments over another 8 spaces to make room. So that's loading a value into R2, and the value I'm loading, I've got square brackets, which means I'm fetching something from memory. The base pointer is R8, that's where the list begins. The value I'm loading, it's index R1, which is where I'm storing I, but it's R1 or I times 4 because each element in the list is of size 4. To increment I, I'm going to say add R1 to R1 to the number 1. So that's going to take 1, the number 1, add it to R1, and store the result in 1. Which is I equals I plus 1. Now I'm going to see if my candidate is, or I'm going to say if this candidate isn't any better than what I had so far, then don't remember it. So I'm going to do a comparison. I'm going to compare my candidate value, which I've got stored in R2, with the so far value, which is in R0. So let's see, for my comment, I'm going to say if candidate is less than or equal to so far. And here for my goto, I'm going to say branch if less than or equal, because the condition right here was if candidate is less than or equal to so far. So I'm going to branch if it's less than or equal to test, which is label 2, and that's forward from my current position. So I'm going to leave that in as a comment, and I'll go ahead and indent it a couple spaces. Otherwise, it follows through, so if this is the new best value that I found, then I'm going to move or copy candidate into so far. So R0 gets R2. And then we have the label 2, which we'd called test before. And now what needs to happen here is I want to do if I is less than size, then go to 1. So I'm going to compare I, which is in R1, with size, which is in R9. My comment will say if I is less than or equal to, or less than size. And then if it is the case, so if BLT for branch of less than, if I is less than size, then I want to branch up to 1, which is now a backwards branch. If not, if it falls through, then that means that I'm finished. So the loop is finished. My value is in R0. So in that case, I'm going to pop R8 and R9 back off the stack. Now notice this time I didn't push LR at the top of the function, and so I can't just pop it off into PC to return from the function. But I do still need to return. Now note that the return address has been sitting in LR this whole time. I haven't overwritten it. So the instruction that tells it to branch to a value in a register is bx. So that's going to go and return from this function. So there's my complete function. And I've basically left the pseudocode over on the right as comments. So you can kind of follow along what it does. So my process was to start with some higher level pseudocode, to go and kind of refine it down to where each line of pseudocode was basically one line of assembly language, one single step. Now what I want to do next is write a main function that can actually use this. Let's see, I'm going to tell it that I've reached the end of my function as well. So I'm going to write a main function, or not a main, a start block that can make use of this. I'll call it start.s. So I'm going to start by saying I'm defining a global label called _start. I'm going to be exiting, so I'm going to define the spell checker likes to come on. I'm going to define sysexit to be 1, as we've done before. Now here I actually want to have some data to use. So I'm going to put this, create a data segment, or go into the data segment. And in it, I'm going to define my list label. Note that I didn't actually use the name list anywhere in the maxlist function. I'm going to pass that address in as a parameter, but the data has to live somewhere, so I'm going to make it here. Word, so I'm going to make some integers in memory. I'm just going to put a list of values here. 3, 9, 7, 1, 3, minus 2, 4. And I'm going to have my size. I'm going to store it in memory. It's going to be current location minus the list divided by 4. Okay, now let's go into the text segment and write start. Before, when we've written start, it hasn't done much. It's just branched immediately to our function. But here, to test this function, I want to actually give it parameters. The function's expecting some parameters. And so if I want it to work correctly, I need to give it those parameters. I need to fill in the values of R0 and R1. So I'm going to load into R0 the location of the list. I'm going to load into R1 the location of the size, and then I'm going to go ahead and load over top of that the actual value of the size. Note again that start is not a regular function because it never returns, and it's called by the operating system instead of being called by some other function. So we don't have the usual rules of registers to worry about here. So I'm just going to load those values, and then I'm going to do a branch with link to maxlist. When it returns, the return value should already be in R0, so I'm just going to prepare for a system call. So I'm going to load a value into R7 that is the sysexit system call number, and I'm going to do service number 0, and that's it. So I've saved both of these files. If I come down into my directory, I've copied over the make file. This is available on the course website. It's also included when you downloaded the project. It's sitting in that directory. I just copied that over. If I type make, it automatically assembles the two files and links them together. I can run it by typing /a.out, and I expect the largest value from that list to be the exit status code, because that was the return value of maxlist, and start used the return value of maxlist as the parameter to exit. So now I'm going to print it out, and I've got the value 9, and that was in fact the largest value from the list. So I'm going to stop there for now, and we'll revisit this later.